Shh. So basically, this guy Gaussian, oh, well, that works. This guy Gaussian realized that when you have 2, 3, 4, 5 infinite variables, a way to solve the systems is using matrices and row reduction. It basically is a really vamped up form of the elimination we learned last class. So he took the elimination that we learned last class and did a whole bunch more to it to solve bigger systems. So it uses matrices and row reduction to solve for variables in systems of equations. I'm sure I spelled matrices wrong, but I tried. Matrices. All right, so here we have a system with how many equations? 3. How many variables? 3, right? For how many variables you have, you need at least that many equations. So if you ever have 3 variables, 4 equations, you really don't need to use that 4th equation. You just need 3. Now, our first step is to take this system and put it into a matrix. So we're going to create our very first matrix. Aren't you so excited? No. I am. So what you do is you create a big square bracket that will fit at least 3 rows because we have 3 equations. And when you're creating a matrix, you're just taking the coefficients from your variables and the constants they're equal to. So what is the coefficient on the x of our first equation? 2. So I'm going to first write a 2. What is the y value of the first equation? 3. So I'm going to put a 3. And what is the z value? Z. 0. There is no z.
Wait, there's 2.
No. In the first equation. In the first equation. There are no z's, so you put a placeholder of 0. That's very important. And then you're going to put a vertical line. And what is that equation equal to? 10. So you put 10 over there. No equals. No equals. So on the second equation, the coefficient on the 4 is the coefficient on the x is a 4. Yep. And the coefficient on the y is a -1. See, it's minus y, so there's an invisible 1 there. So it's -1. And the coefficient on the z, and what it's equal to. And the coefficient on the x of the third equation.
1.
And the coefficient of the y. And the coefficient of the z. Good. And perfect. We just completed our first matrix.
So what when we do? What is?
Nope, she's gonna trick us.
No, she'll be like
This.
man, you have to
So right. This is the starting point. Right? Nothing has been solved yet. We haven't done anything to this matrix. A matrix is just an easier way to look at your values. It's just like a simplified, easy, quick glance way to look at it. Okay? Right. Okay, so this is where you start, your starting point. Now, to solve a matrix, you solve using what is called row reduction. Now, the reason it's called row reduction is, even though these are in the matrix, these are still representing equations. So if I were to multiply this top 2 by 4 and pretend this is an equation, what else do I need to do? Multiply the entire row by 4. So you're working with entire rows at a time. That's why it's called row reduction, because you're working with the rows. You'll see what I mean. And you can perform any of the following operations on the entire row. So the first thing you can do, which I don't think that we'll get this far in depth with it, but you can swap rows. You can add or subtract rows. And you can multiply or divide. Whoops, multiply. Row.
Yeah, I saw that.
Rows.
That down.
You wrote it? You were going to write it? Okay. Now, in order to know we are done row reducing, creating our identity matrix, what will tell you you're done is if you have ones on the diagonal with zeros above and below. Now, if the zeros were just below, that's actually called reduced echelon form. We're not going to get into that. If you have zeros above and below, that's called creating the identity matrix. Again, not vocab you need to know. Not vocab you need to know.
So we don't need to know what that.
No. I'll show you what it's supposed to look like. That's what you're supposed to know. So here, this is our matrix. Pretend on another sheet I have done all these row reductions. Your end result is going to look like, I think I memorized it. Your end result, if you did everything correctly, is going to be 1, 0, 0, line 2, 0, 1, 0, 2, 0, 0, 1, 3.
Can you explain?
So calm down. Remember how I said there's going to be a bunch of examples? Just wait until I'm done with the notes. I am just showing you what your end result has to look like, okay? So do you see, right, do you see that there are 3 ones on this diagonal and there are zeros below it and zeros above it? Yes, this is completed. How you read this? What variable did that first one represent? X. So here this reads x is equal to 2. And what did the 1 in the center, what variable did that represent? Y. So y equals 2. And what did that last one represent? So z is 3. Oh, we solve for the 3 variables. We haven't row reduced yet. I'm just showing you what the end result has to look like.
So how did you get the 2s?
I have not showed you how to solve it yet.
Why do you teach us the end?
Because it's very important to know what the end result has to look like. So we know how you start, we know how we end. We end with the ones on the diagonal. It's good to see this because it gets kind of convoluted when you're solving it. But as long as you have the end result in mind, you know what we're working towards. Okay? Everyone has to end just like this, with ones on the diagonal and zeros below and a zeros above. These numbers will change based on the system, yes. Because sometimes x will be equal to 9 or negative 3. We don't know. It's individual to each system, okay? So let us now do some examples. So open up your folder, your foldable there. Open the first flap.
Is this gonna be on the test?
Mm-hmm.
Yes.
Mm-hmm. All right. So your first flap has 2 sides, right?
Yeah.
Like this. This side over here is going to be your scratch work. So you put scratch work. This is work that I and linear algebra students would probably do in their head. But I want to make sure that you know all of the steps that are happening. So we're going to do scratch work over here and then actually solve on the right-hand side. So the first example is x plus 5y equals 7 and negative 2x minus 7y is equal to negative 5. So from what we learned last class, to solve this system, do we have to do Gaussian elimination? No, we just learned how to do substitution and elimination, right? Well, I wanted to start with a simple matrix to show you the most basic way you can do Gaussian, okay? And then next we'll do a 3 by 3. We'll make it a little harder on the next example. So, what do you think is my first step? Okay. So, make my matrix. This is just going to be a 2 by 3 matrix. So, what is my first coefficient on x? 1. And what's my coefficient on y for my first equation? And it is equal to? And then my first x on the second equation is? And my y on the second equation? And it's equal to? Woo! We just completed our first matrix, creating our first matrix. Now, yeah, right, that's the easy part. When I am doing row reductions here, I'm going to call this top row, row 1, and the second row, row 2. That makes sense, right? So this is row 1, R1, and this is R2. Now, what do you see that is good already about this matrix? It already has the 1 for the very first x in row 1. Perfect. So as a rule of thumb, when you're doing row reductions, you always want to work left to right. So we're first worrying about this first column. We got a 1, which is great. You always want to get the 1 first. Then what needs to happen? The negative 2 needs to become a 0. So what can I do to get that negative 2 a 0? Okay, add 2. Now I have to get that add 2 from a different row. So just like we did in elimination, remember how we multiplied the first equation by a number that would make that first number cancel with the second? Same thing here. We're going to multiply row 1 times 2 and add it to row 2. So this is how I'm going to write it. I'm going to write row 2 plus 2 times row 1. Now, because I wrote that little expression next to row 2, that means row 2 is going to be the thing that's changing. Row 1, we're just rewriting. It does not change. So you draw a little arrow and you rewrite your matrix, keeping the top row the same. But the bottom one's going to change, so I'm going to leave it blank for now. So over here on the scratch work, the very first scratch work I'm going to complete is row 2 plus 2 times row 1. What is the x value of row 2? Negative 2, so I'm going to put a negative 2 here, plus 2 times row 1. What is the x value of row 1? 1. So, what is negative 2 plus 2 times 1? 0, which is what we wanted. Right, so we got a 0 here. Now, I need to do it for the y value and also for the constant. So, what is the y value of row 2? Negative 7 plus 2 times the y value of R1. 5. So what's negative 7 plus 2 times 5? 3. So I put a 3 there for my new y value. And what is the constant for my row 2? Negative 5. And what's the constant for my row 1? So what is negative 5 plus 2 times 7? So my new constant for the second row is 9. So now my first column is done. What comes next, do you think? What about the second column? First, always get the 1. First, always get the 1, then get your zeros, okay? So we need to get this 3 to be a 1. How could we do that? Divide by 3 or multiply by 1/3. So the rule of thumb is when you're adding or subtracting, you have to add or subtract another whole row. When you're multiplying or dividing, you can just multiply or divide that row. You'll see, it'll make more sense in the second example. Okay, so here I have to multiply by what?
Divide by 3.
Divide by 3, good. So I'm running out of room on this row. So I'm going to go down. And I'm going to multiply row 2, or I'm going to divide row 2 by what?
3.
Divide it by 3. So I'm going to, in my scratch work over here, divide row 2 by 3. Now, which row am I changing? The second one. So I copy over the first again. And again, I'm changing the second row. I'm going to do a different color so you can see. What is my row 2 x value? So what's 0 divided by 3?
0.
So do you see why I didn't add or subtract this time? Because if I had added or subtracted, I would have had to give up this 0, which I just worked so hard to get. Okay? So what is my y value of my row 2?
3.
So 3, what is 3 divided by 3? 1. Is that what I wanted to get? Oh, yes, it was. And my constant for row 2?
9.
What's 9 divided by 3? 3. Okay. And what is so now I have my second one. I have my ones in the diagonal. What is the last thing I need to do? Make the 5 a 0. How can I make the 5 a 0? So, this is good. If I multiply this row by 0, everything is gone, losing my very important 1. So, what should I do? If I divide by 5, what also changes? The 1. Subtract which one? So if I subtract everything by 5, remember, look what I did here. I did row 2 plus 2 times row 1 to cancel these. So here, to get rid of the 5, I can do row 1 minus 5 times row 2. Row 1 minus 5 times row 2. So I'm running out of room again. So my row 2 is staying the same. I copy 0, 1, 3. Now I want to do row 1 minus 5 times row 2. So what is my x value for row 1? 1. So 1 minus 5 times, what's the x value for row 2?
0.
What's 1 minus 0? Oh, so it stayed the same, which is good. We need that one. And then our row 1 y value is 5 minus 5 times our row 2 value, which is 1. So what is 5 minus 5? 0. Perfect. So now I have ones in the diagonal and I have my zeros where I need them. And very lastly, my row 1 constant is 7 minus 5 times my row 2 constant, which is 3. What is 7 minus 15? Negative 8. Am I done? Yes, I am. All I have left to do is just write x is equal to negative 8 and y is equal to 3. Whew! So, yes, here you can, oh gosh. However, most times There's going to be 3 variables, so you don't need to. All right. I know this seems overwhelming. It's okay. We're going to do one more example. This time, 3 variables.
Is that easier?
You know, I really want to tell you yes.
It looked easier.
Did it?
Yeah.
All right.
But, I mean.
So again, we have our scratch work.
Is this on the second part?
It is on the second flap, beneath.
I was trying to like save room.
Oh no! Oh gosh, no! No. The top had one problem and the bottom has another. Yeah. All right, so our second example is x plus 3y plus z is equal to 10. X minus 2y minus z is equal to negative 6. And 2x plus y plus 2z is equal to 10. All right, so what is the first thing we're going to do here? Put in your matrix. So we have 1, then 3, then 1, then 10, then negative 1, negative 6, 2, 1, 2, 10. So lots of 1s are good. Again, we're starting with 1 in the top corner, which is great. We don't have to get that 1, it's already gotten. Yes?
Does it matter which way the diagonal goes?
So good question. Doesn't matter what way the diagonal goes. I'm going to tell you that every professor everywhere always does left to right diagonal. However, and the last class asked the same thing. Can you go this way? I think you'll get the same answers, but it's poor form. Go this way. Left to right diagonal. All right. So, what do we need to do first? Left to right, good. So in our leftmost column, we have a 1, which is great. What now needs to happen? I need to do what below the 1? Make these zeros. Now, you can do 2 operations in one go. So, I already have the 1 up top. Now, I can somehow get this to be a 0, this second row. How would I do that? Minus, so row 2 minus, oh, yes. Row 2 minus row 1. And then, how would I get this 2 to be a 0 below it? So, row 3 minus, what would get this to be a 2? 2 times row 1. So, row 3 minus 2 times row 1. We don't want to do minus 2 times row 2 because we're about to change that row. All right, so first, row 2 minus row 1. We're going to draw our new matrix. The top row is not changing. Oh, what am I doing? The issue is that these problems take a long time and class ends in 11 minutes. So, yeah, this problem's going to take longer. So, row 2 minus row 1. What is the x value of row 2? 1. And what is the x value of row 1? 1. What's 1 minus 1? 0. So that first value is 0. What we wanted. Good. We did it right. What is the y value of row 2? Negative 2 minus the y value of row 1? What is negative 2 minus 3? So negative 5 goes here. And what is the z value of row 2? Minus the z value of row 1. What is negative 1 minus 1? Negative 2. And the constant, negative 6 of the second row minus the constant of the first, which is 10. Negative 16. Good. Whew. We want to get ones on all the diagonals.
So why do we have to solve the rest of it?
Because whatever you do to one thing, you have to do the other in an equation, remember? In any equation, ever solving, whatever you do to one side, you have to do the other. Same concept. Okay, so now we're going to do the row 3 minus 2 times row 1. What is the row 3x value? 2. Minus 2 times, what's the row 1 value? 1. What's 2 minus 2? 0. Oh, what we wanted. The row 3 y value is what? 1 minus 2 times the y value of row 1. 3. Which 1 minus 6 is? Negative 5. The z value of row 3 is 2 minus 2 times the row 1 z value, which is? What's 2 minus 2? Ooh, got another 0. Not where we wanted it. All right. Then the the constant row 3 value is minus 10. Good. 2 times 10, sorry. 2 times 10, which gives us negative 10. Okay. Whew. Yeah, I wish. So, good. Now, unfortunately, I may have picked a more complex problem. What do you see that could trip us up in the future?
The 0 at the right bottom.
The 0 where?
At the right bottom.
Right here.
Yeah.
So do you remember how I said we could swap rows?
Yeah.
We can make this our second row. We're going to swap these rows right now. It's no big deal. It's no big deal. Because we need a 1 to be in that 0 position. We need a 1 to be in this 0 position. It's going to be impossible to make that 0 a 1 at this point.
Say there was no 1 in the left-hand corner. It was on row 3. Could you switch?
Yes. So we're just going to swap those rows. Yep. You're just switching the numbers. So now it's going to be 1, 3, 1 stays the same with a 10. But then it's going to be the last row moving to the middle. Oh no, it's about to crash. Don't do it. What are we going to do to this negative 5 to make it a 1?
What?
So remember, when we're just trying to get 1s, we can divide and we can multiply. So what could I do to negative 5 to make it a 1? Divide by negative 5. So I'm going to divide everything by negative 5. Row 2 divided by 5.
It's negative 5, right?
Sorry, thank you. So I copy down everything in the first row and everything in the last row. Those don't change. 1, 3, 1, 10, and 0, negative 5, negative 2, negative 16. What is the x value of R2? 0. So what's 0 divided by negative 5? 0. So it remains the same. That first value remains 0. Then, what is the y value of row 2? What's negative 5 divided by negative 5?
1.
So I put a 1, which is what we wanted. And then what's 0 divided by negative 5? And negative 10 divided by negative 5. Whew! All right. Now what needs to happen?
The 5 needs to be 0.
The negative 5 needs to be 0. What else? And the 3. Both of those. So how could we get this 3 to be a 0? If you subtract what?
3.
Row 1 minus?
Row
3 times row 2. And then what can we do to this last row to make the negative 5 a 0? Yes. So the second row is remaining the same this time. So the second row remains the same. 0, 1, 0, 2. We have 2 more minutes. Good try, though. 2. 1. All right. So I think that we're going to put a pause on this. You're going to have to look online to finish the problem. And this is your homework problem.
Let's just come back and be like, all the stuff.
On a separate sheet of paper, do this homework problem. X plus 3y minus 3z is equal to 12. And then 3x minus y plus 4z is equal to 0. And negative x plus 2y minus z is equal to 1. All right, so before the end of class, we had been given a homework assignment, and then I said that I would record this and you guys had to watch it. So we had decided that this first row right here, we had to take it and subtract 3 times row 2 to get rid of the 3 and make it a 0. And then also to row 3, we had to take row 3 and add 5 times row 2 to get rid of that negative 5 right there. So over here, we're going to have some scratch work. Row 1 minus 3 times row 2. So that first row we're going to deal with first. Our x value for row 1 is 1. Minus 3 times row 2, the x value is a 0. So 1 minus 3 is, 1 minus 3 times 0 is 1. So I'm going to put a 1 in that first position. Then we're going to do our y values. So our row 1 y value is a 3 minus the row 2 value times 3. So 3 minus 3 is 0, which is what we wanted. Then the z value, which is 1, minus 3 times the row 2 z value, which is 0. So 1 minus 3 times 0 is 1. And then our row 1 value, that is a constant, is 10, minus 3 times the row 2 value, which is a 2, or row 2 value. So 10 minus 6 is 4. So there we have the row 1 taken care of. Now we just have to do our row 3. I'm running out of room here. So we have our row 3 plus 5 times row 2. So our row 3 x value is 0 plus 5 times our row 2 value, which is also 0. So that ends up being 0. Then row 3 value is negative 5 plus 5 times our row 2 value, which is 1. 5 plus 5 is or negative 5 plus 5 is 0, which is what we wanted. And then negative 2 is our z value for row 3, plus 5 times the row 2 value, which is a 1. Oh, sorry, 0. So negative 2 plus 5 times 0 just remains negative 2. And then negative 16 is our constant for row 3, plus 5 times the constant of row 2, which is 2. So negative 16 plus 5 times 2 is 10, so negative 16 plus 10 is negative 6. So now we have completed our second column, this column right here. We have 1 in the middle and 0 above and 0 below. Now we just have to deal with this last column here, where remember the first thing we have to do is get the 1 where we want it. So we want to make this negative 2 into a 1 so that we have our diagonal 1s. Now, to get negative 2 to be a 1, all I have to do is divide this last row by negative 2, or multiply by negative half. So I'm going to take row 3 and divide by negative 2. Row 1 stays the same, and row 2 also stays the same. The only thing changing is row 3. So 0 divided by negative 2 is 0. 0 divided by negative 2 is 0. Negative 2 divided by negative 2 is 1. So we did something right there. And negative 6 divided by negative 2 is a 3. So now there's only one more thing we need to do. We need to get everything else besides this last one a 0. So above this 1, we need to make this top z value for row 1, we need to make that a 0. So what we're going to do is to row 1, we are going to add, we are going to subtract row 3. The reason why we subtract here is because instead of just multiplying by 0 is 1, because multiplying by 0 will take out that entire row. And also, when I'm subtracting row 3, I'm not changing that very important 1 value in front. I need to keep that a 1. So by subtracting row 3, 1 minus 0 remains a 1. So that's why here I'm subtracting. So over here, my scratch work, I'm going to do row 1 minus row 3. My row 1 x value is a 1 minus my row 3 value, which is 0. So good, that remained a 1 just like I wanted it to. So my very last step, my first x value is going to be a 1. Then my row 1 x value is 0, or y value is 0, minus the row 3 y value, which is also 0, so this remains a 0. And then my row 1 z value is 1, minus the row 3 value, which is a 1. So that's 0, just like we wanted it to be. And then my row 1 constant is 4, minus my row 3 constant, which is a 3. 4 minus 3 is 1. And then the other two rows remain the same, so I'm just going to copy them down. And there we have it. We have now created the identity matrix over here on this left-hand side. And how this is read is x, this first one represented in x, so x is equal to 1. Then this, in this row 2, this y value is equal to what the constant is now, which is a 2. And the z is equal to the constant 3. And we are done row reducing, and we have solved this matrix.